Two ships, same darkness. April 1970. Three astronauts huddle inside a freezing lunar module. Their oxygen tank exploded. Their landing dreams abandoned. They are 248,655 miles from Earth, farther than any humans had ever been. The cold is biting, power is failing. They are fighting for their lives with duct tape, prayer, and sheer willpower. April 2026. Four astronauts float inside the Orion spacecraft, officially named Integrity. Warm lights glow softly. Coffee drifts in zero-gravity bags. Someone laughs as a packet of Nutella slowly tumbles past their faces. They are about to travel roughly 252,760 miles from Earth, farther than anyone in history. And this time, they are doing it deliberately, with years of preparation and the eyes of the world watching. This is not the moon mission your parents watched on grainy television sets in 1969 or 1970. This is Artemis II, the first crewed mission to leave low Earth orbit since Apollo 17 in 1972. What these four astronauts will actually experience, the breathtaking sights, the eerie silence, the strange smells of recycled air, the floating freedom, the moments of pure terror, and the overwhelming wonder, is unlike anything any human has ever felt before. But to truly understand where they are going, we first have to understand where we've been. Because while the moon itself has barely changed in billions of years, cold, silent, and unforgiving, everything else about how we reach it has evolved dramatically. The technology, the safety mindset, the diversity of the crew, and even the purpose of the journey have all transformed. Yet in the quietest moments, when the radio goes silent and Earth disappears behind the lunar horizon, the fundamental human experience remains hauntingly the same. The machine, from tin cans to deep space minivans, the Apollo astronauts flew in a command module that offered less habitable space than a small Volkswagen Beetle. 3 grown men, 6 days, 1 tiny metal cabin. They affectionately, and sometimes bitterly, called it a tin can. By comparison, Artemis II's Orion spacecraft provides the crew with significantly more room, roughly 331 cubic feet of habitable volume, about 50% more than Apollo's command module. For 4 people on a 10-day mission, it's still relatively cramped, but it feels like a spacious, deep space minivan next to Apollo's claustrophobic capsule. NASA even describes the layout as open concept, with better designed sleeping areas and workstations. The differences begin right at launch. Apollo rode the colossal Saturn V, a towering 363-foot single-use beast that thundered into the sky and crashed its stages into the ocean after every flight. Artemis II uses the Space Launch System, SLS, which incorporates reused components and booster casings from the Space Shuttle program. It's still a powerful expendable rocket, but it carries the DNA of more modern engineering. Yet some fundamentals remain unchanged. Both missions burn the same basic rocket fuel: liquid hydrogen and liquid oxygen. As one veteran rocket engineer once quipped, the core concepts of chemical propulsion haven't really changed in 70 years. No one has invented a warp drive yet. Where the real revolution has occurred is inside the spacecraft's brain. Apollo's guidance computer had only 74 kilobytes of memory and 4 kilobytes of RAM. Less computing power than a modern digital watch. One misplaced keystroke during Apollo 8 nearly sent the spacecraft off course. Orion's command and data handling system is orders of magnitude more powerful. It can run complex autonomous operations, predict potential failures before they happen, and maintain constant communication with Earth with minimal crew intervention. The spacecraft is smarter, safer, and far more capable of looking after itself. And yet, the heart of the entire operation remains strangely familiar. The nerve center is still the Christopher C. Kraft Jr. Mission Control Center in Houston, Texas. The same building, the same call sign, Houston, and many of the same traditions that have existed since the 1960s. Different century, same voices, same quiet tension in the room when something unexpected happens. The journey, breaking a record. No one wanted to break. Apollo 13 never intended to set any distance record. After the oxygen tank explosion turned their mission into a fight for survival, the crippled spacecraft was forced into a desperate free return trajectory around the moon. That unplanned loop carried them to 248,655 miles from Earth, a number born not from ambition, but from pure necessity and brilliant improvisation on the ground. Artemis II is deliberately chasing and surpassing that same mark. During the mission, Orion flew within approximately 4,070 miles of the lunar surface before swinging out to a maximum distance of about 252,760 miles from Earth, beating Apollo 13's record by roughly 4,100 miles. For the Apollo 8 crew in 1968, simply reaching the moon was an enormous gamble. There had been no prior crewed test flight of the Saturn V with humans aboard. The service module engine had never been tested in deep space with a crew. A single malfunction could have meant certain death. The space race demanded speed over perfect safety. Artemis II took a far more cautious path. An uncrewed test flight, Artemis I in 2022, flew first, carrying mannequins to measure radiation, vibration, and re-entry stresses. No shortcuts, no gambling with human lives. The trajectory itself tells the story of progress. Apollo 13's path was calculated in real time using slide rules, handwritten notes, and desperate prayers. Artemis II's elegant figure-8 trajectory was modeled for years on powerful supercomputers. In fact, the first planned trajectory correction burn was canceled because the spacecraft was already flying so precisely. Yet for one profound moment, both missions share the exact same experience. When Orion slips behind the moon, it enters a roughly 40-minute communications blackout. The lunar terrain completely blocks radio signals to Earth. Houston goes silent. The crew is utterly alone in the universe. The Apollo astronauts knew that terrifying silence intimately. For them, it often meant frantic problem-solving under extreme pressure. For Artemis II, the blackout was expected, modeled, and prepared for. The spacecraft would re-emerge right on schedule with stable systems. But the raw human feeling, being the only 4 humans on the far side of the moon, with Earth completely hidden from view and nothing but stars and silence surrounding them, that deep existential solitude has not changed in more than 50 years. What they see, the view no human has ever seen. When Apollo 8 rounded the far side of the moon on Christmas Eve 1968, astronaut Bill Anders lifted his camera and captured one of the most iconic images in human history. Earthrise, our small, fragile blue planet rising above the barren gray lunar horizon, a photograph that helped spark the modern environmental movement. Artemis II has given us something equally stunning. Earthset, our beautiful home planet slowly setting behind the rugged, pockmarked edge of the moon. The images released by NASA are breathtaking in their clarity and emotional power. But that's not the only new perspective they gained. The crew spent hours surveying the lunar far side in much better lighting conditions than any Apollo mission ever achieved. Commander Reid Wiseman remarked with genuine excitement that while we had seen these regions in satellite photos, humans have never ever seen that before. That's cool. They also witnessed a total solar eclipse from lunar orbit, the moon perfectly blocking the sun, leaving only the glowing white corona visible in the blackness. Unlike the Apollo crews, who were mostly fighter pilots given crash courses in geology, with the Artemis II astronauts are trained scientists. Christina Koch brought experience from extreme fieldwork in the Arctic and Antarctic. Jeremy Hansen holds a master's in physics. The entire crew trained extensively in Iceland and Arizona, learning to describe lunar features with scientific precision and poetic clarity. In one training simulation, an astronaut described a rock formation as looking like a kiss. That kind of trained human observation matters. During Apollo 17, the crew spotted orange soil from orbit, something no automated camera would have flagged as special. That soil turned out to be ancient volcanic glass from an eruption billions of years ago. The question now is, what subtle wonders will the Artemis II crew notice with their trained eyes and minds that no instrument or satellite has ever captured before? A life inside. The toilet, the Nutella, the silence. Let's be honest, this is what many people are most curious about. What is daily life actually like inside a spacecraft 250,000 miles from home? Apollo's answer was blunt, not great, The bathroom situation was notoriously primitive. Male astronauts used urine collection bags with cuffs. Everything else went into plastic bags that had to be sealed and stored. On Apollo 10, mission commander Tom Stafford famously complained about a turd floating through the air, a moment that became legend. Artemis II has the Universal Waste Management System, a modern, suction-based toilet designed to work for both men and women, similar to the one on the International Space Station. Early in the mission, the vent line clogged with frozen urine. The crew solved it creatively by reorienting the spacecraft to point toward the sun and thaw the ice. If the system fails completely, they still have backup procedures reminiscent of the Apollo era. Food has improved enormously. Apollo astronauts ate mostly freeze-dried cubes and tubes. Artemis II has a menu with nearly 190 items, including shrimp cocktail, brisket, mac and cheese, and, a crew favorite, Nutella that floats gracefully in zero gravity. Sleeping arrangements are creative rather than comfortable. There are no traditional beds. Crew members strap sleeping bags to the walls, ceiling, or even the docking tunnel. Christina Koch prefers sleeping heads down like a bat. Commander Reid Wiseman positions himself under the control displays so he can quickly check systems if he wakes during the night. The cabin temperature can fluctuate. Windows heat up from direct sunlight, so the crew uses t-shirts and improvised shades. They exercise daily on a compact flywheel device the size of a shoebox to combat muscle and bone loss, something Apollo crews lacked, leading to significant weakness upon return. Every morning they provide saliva samples for immunology studies. They wear sensors that continuously track sleep quality, stress levels, and radiation exposure. In many ways, it's the astronauts themselves have become floating scientific laboratories. And yet, through all the routines and minor inconveniences, the view from the 6 windows never fails to humble them. A tiny blue marble slowly shrinking behind them, and the ancient cratered moon growing larger and more detailed ahead. It's a strange mix of high technology, everyday human moments, and profound cosmic perspective. The challenges. What can still go wrong? Despite all the advances, deep space remains incredibly unforgiving. The Artemis II crew has already dealt with several real issues during the mission: a clogged toilet vent line, a finicky water dispenser that required them to bag water as a precaution, and a minor redundancy loss in the helium pressurization system. All were resolved, but they served as reminders that even advanced systems can surprise you. The greatest challenge, however, is not any single piece of equipment, it's the sheer distance. At roughly 250,000 miles from Earth, there is no quick rescue option. Unlike the International Space Station, which orbits just 250 miles above us and can be reached in hours, Artemis II is truly on its own. If something goes seriously wrong, the crew must solve it with whatever they have on board. Apollo 13 taught the world this lesson the hard way. After the explosion, the crew had to use the lunar module as a lifeboat, and engineers on the ground improvised a carbon dioxide scrubber using duct tape, plastic bags, and spare parts. Survival came down to ingenuity, luck, and calm under pressure. Artemis II has far better redundancy and training, but the fundamental truth remains. When you're that far from home, you are ultimately responsible for your own survival. The final and most dangerous test will be re-entry. Orion will slam back into Earth's atmosphere at approximately 25,000 miles per hour, one of the fastest crewed re-entries ever attempted. The heat shield, made of an improved version of Apollo's Avcoat material, will face extreme temperatures. NASA already adjusted the trajectory to a steeper angle to reduce risk based on data from the Artemis I test flight. If everything goes according to plan, the crew will splash down safely in the Pacific Ocean around April 10th or 11th, 2026. And this time, they won't face weeks of quarantine. The emotional core, why this mission matters. On April 6th, 2026, as Orion passed the far side of the moon, one Canadian astronaut Jeremy Hansen made a special request to Mission Control. "We lost a loved one," he said. "Her name was Carol, the spouse of Reid, the mother of Katie and Ellie, and we would like to call this bright crater Carol." 45 seconds of silence followed on the live feed. Commander Reid Wiseman's eyes filled with tears. The crew floated together in a group embrace. Back on Earth, his 2 daughters watched from Houston, deeply moved. It was one of the most human moments of the entire mission. Apollo 8 read from the book of Genesis on Christmas Eve while orbiting the moon. They were military test pilots, products of the intense Cold War space race. Artemis II represents something different. The crew is diverse. 3 Americans and 1 Canadian, 2 women and 2 men, including the first indigenous astronaut to travel into deep space. This mission symbolizes international cooperation, scientific curiosity, and a more inclusive vision of exploration. For more than half a century, 54 years, no human had left low Earth orbit. Artemis II marks humanity's return to deep space. The moon itself hasn't changed. It remains the same silent, cratered world it has been for billions of years. But we have changed. Our technology is better. Our understanding is deeper. Our reasons for going are broader. When the crew looks back at Earth from 250,000 miles away, seeing it smaller than a dime held at arm's length, floating vulnerably in the blackness, they witness the same fragile blue marble that the Apollo astronauts saw. But this time, perhaps we will remember more clearly how precious that small world is, and why the urge to explore has never truly left us. As one Apollo astronaut reflected when asked why humans keep pushing outward, "We're humans. That's what we've always done. From the time our ancestors left Africa, expansion has been part of our psychology." Artemis II is not just a test flight. It is proof that the desire to reach beyond our home, to touch the unknown, still burns brightly. The moon is waiting, and we are finally ready to go back. Not to win a race, but because it is who we are.